Alright, so let's get started with 12.1. We're going to be talking about systems of linear equations, substitution and elimination. So this should be review partly from Algebra 1. And so what I need you to do here is go ahead and look at problems 9 and 19 in the textbook and try those problems. Check the back of the book. If you can do those problems easily, you're in good shape. If not, go look at part 1, the video part 1 I did that walks you through these steps, and we'll be able to get you caught up to speed on substitution and elimination for systems of equations. What I'm going to do now is jump up to objective 3. Went too far. There we go. Alright, and we'll start from here. So if you feel comfortable with elimination and substitution for two variables, this is the right place to start. So again, do problem 9 and problem 19. If you can do those comfortably, jump right in here. If not, go back and watch video part 1. Alright, so we need to identify inconsistent systems of equations containing two variables. Inconsistent is again where we have parallel lines that are not going to cross, so we're going to have no solution. So this one, I'm going to go ahead and do this with elimination. Oops, I apologize. Let me get the pen working. And let's have a nice black pen. There we go. Alright, so I'm going to multiply the bottom equation by 3. And so equation 1 was 3x plus 6y equals 12. Equation 2 is going to be 3x plus 6y equals 21. We'll subtract down. That'll cancel the x's, and it'll cancel the y's. We've got 0 equals negative 9. Is 0 ever equal to negative 9? No, it's not. So we are inconsistent. And we have no solution. Alright. Now what happens though if we have two lines lying on top of each other? So in this equation here, I'm going to multiply the top equation times, let's go with 3, and the bottom equation times 2. So we'll have 18x minus 12y equals 24, and we'll have negative 18x plus 12y equal to negative 24. And let's go ahead and add straight down this time. Those will cancel. Those will cancel. Those will cancel. We've got 0 equals 0. When is 0 equal to 0? Always. We have all real solutions. In fact, all imaginary solutions would work here as well. 0 is always equal to 0, so all solutions. And we have a dependent system of equations. Alright, which means that that line and that line are the same. They're lying on top of each other. Alright, so knowing that, try problems 25 and 29. Alright, now let's move on to three variables. So things get a little tougher here. We have three different planes. Where do they intersect? Maybe once, so we'd be consistent. Maybe they intersect all in a nice straight line, so we would be consistent still, but we would be dependent, having an infinite number of solutions. And maybe there's no point where all three of them intersect. Maybe two of them intersect, but not all three of them intersect, or maybe we're all parallel and we don't intersect anywhere. So let's find out what we've got here. Use elimination to solve three sets of equations, a three-variable system of equations. So first thing we're going to do is we're going to match up equation 1, 2x plus y plus z equals 4, with equation 2, negative 3x plus 2y minus 2z equals negative 10. Let's go ahead and multiply equation 1 by 2, so we match up. So we'll have 4x plus 2y plus 2z equals 8. So I multiplied this one by 2. And let's go ahead and how about let's go ahead and subtract down. We'll cancel out the y's here. Could have added also. That would have canceled out the z's. Alright, negative 3 minus 4 is negative 7x. And negative 2 minus 2z is minus 4z equals negative 18. Okay, separately. So this was equations 1 and 2. Now we're going to go with equations 1 and 3. So 2x plus y plus z equals 4. And just for space sake, I'm going to take equation 3 and times it by let's see. Oh, nope. Hold on one second. Not ready for it. Getting ahead of myself. There's equation 3. I need to make sure the same variable disappears. So over here, y disappeared, right? It's gone. So we need to make sure y cancels out over here also. So let's take equation 1 and times it by 2 so that we'll have the same amount of y coefficients. Plus 2y plus 2z equals 8. So we'll need to add straight down. So we'll have 5x plus 5z equals 15. All right, now we're getting somewhere. We've gotten rid of y. We're going to rewrite the two equations we've created and put them right on top of each other. Negative 7x minus 4z equals negative 18. We've got 5x plus 5z equals 15. We've got to get rid of one of these variables. So let's go ahead and multiply. Let's get rid of the z's. We'll multiply the top equation times 5 and the bottom equation times 4. And so we'll have negative 35x minus 20z equals negative 90. And then we'll have 20x plus 20z equal to 15 times 4 is 60. And we need to add these together to get the z's to cancel out. So we will have negative 15x equal to, z's are gone, add those together, negative 30. X is, oh, now we're getting somewhere, x is 2. All right, let's go back in and plug this in somewhere to get a z. How about this equation? 5 times 2 plus 5z equals 15. So 10 plus 5z equals 15. 5z equals 5. Z equals 1. All right, so now x is 2, z is 1. Can I squeeze it in somewhere else on the slide? How about up here? Let's go back to any equation we want. We'll just go to this first one. That's fine. All right, so 2x. 2 times 1 plus y, don't know y yet, plus z, so plus 1 equals 4. All right, so 2 plus 1 is 3, plus y equals 4. 4 minus 3 is y equals 1. We've got three different variables. We've solved all of them. We're going to write this as x, comma y, comma z. And we are in business. All righty. Let's, go ahead and try problem 43. 43 is yours to try. Oh, you know what? I caught my mistake here. X is 2, isn't it? Ah! Here we go. 2 times 2. I apologize. We got to go back and clean this up. 2 times 2 is 4. Plus y plus 1 equals 4. And so those 4's will cancel. Y is going to be negative 1. Thought that looked wrong from when I did it earlier. Y equals negative 1. So final solution here, x is 2, negative 1, and positive 1 for our final solution. All right, so go ahead and try problem 43. Okay, objective 6. Let's identify inconsistent systems of equations containing 3 variables. So, 2x minus 3y minus z. That's equation 1. Let's line it up with equation 2. And the z's are lined up nicely. Let's get rid of them so we can add straight down. And so we'll have x minus y equals 0. Z's are out of here. And let's go with equation 1. 2x minus 3y minus z equals 0. And we have 3x minus 4y minus z equals 1. Here we're going to have to subtract straight down to cancel the z's out. So we'll have negative x, and minus a negative is a plus. Negative x plus y equals negative 1. Here, let's take our two equations and line them up. X minus y equals 0, and negative x plus y equals 0. And to cancel out the x's, we could add. But that also cancels out the y's, so we've got 0. It's alright. Negative 1 over here. And if we add straight down here, we've got negative 1. Does that work? No. So right away we know this is an inconsistent system. This is not going to work. We have no solution. Alright, no solution for that one. Alright, objective 7 here, we are going to skip over objective 7 for now, and we're going to go over objective 7 in class together. Objective 7, all sorts of things going on here, so I want to make sure we're okay with that. Try problem 45 on your own. Just take a peek at it. If you think you can get it, great, but we will definitely go over this one in class. You can see there's a lot of action going on here in problem 45. I want to make sure we walk through it together. So we're going to skip that and then just finish up here with some curve fitting. What curve fitting means here is we've got an equation for a quadratic. We've seen that before. And this has 1, 2, 3, ABC, 3 variables. So we're going to need 3 equations. To do that, we would need 3 points on the line. So here's what we're going to do. We're going to rewrite this equation, only instead of y, plug in some points we've got. Y is negative 4 from the first point. X is negative 1. Plus B, negative 1. Plus C. Point 2, the y value is 6. And so then we have 6 equals a 1 squared plus B times 1 plus C. And the last equation here, we've got 0 equals a 3 squared plus B times 3 plus C. Let's clean all these up here. We've got negative 4 equals 1a plus, minus B plus C. And then we also have 6 equals a plus B plus C. And then we have 0 equals 9a, 3 squared, plus 3b plus c. Hey, look at that. We've got 3 variables and 3 equations. Let's see if we can solve here. I'm going to take this equation and put it over here. 6 equals a plus b plus c. Let's go ahead and subtract straight down. We're going to have negative 10. A's will cancel. Equals negative 2b. C's cancel. That's nice. So negative 10 divided by negative 2 will be 5, which is what b is equal. And so let's go back in over here. We've got 6 equals a plus 5 plus c. Just substituting in for b. 0 equals 9a plus 3 times 5 is 15 plus c. And so now we've got 1 equals a plus c. And we've got negative 15 from this one here equals 9a plus c. If we subtract down, the c's are going to cancel. We've got 16 equal to negative, is that right? Is that a negative 9? No, it's not. Just wanted to make sure. Negative 8a, so a is equal to negative 2. And did I lose a negative? Let me check 1 second. I think that looks all right. Check that. I may have lost a negative in there. A lot of things going on here. And last one, we're going to plug both of these back in for C. So let's go back to an easy one. How about this one right here? 6 equals A, which is negative 2, plus B, which is 5, plus C. So let's see, let's move this around. So negative 2 plus 5 is 3. Subtract those. We've got 3 equals C. And so there we go. Y equals A plus B, where'd B go? Plus 5x plus C. We've got ourselves an equation. All right, that's it. Problem 69 is yours to solve. Wrap that up. Any questions, make sure we're asking them in class. But good luck.